Titansoft is a software consultancy and development company that specializes in the gaming and entertainment industry. Since day one, Titansoft has strived to find better ways of working. I think it's a recognition of our never stop improving spirit, which is very critical in our young industry. So we try to create an environment which is flat and open, and we introduce many new methods like Scrum and Agile, and also like pair programming, continuous integration, continuous delivery. So every day we can learn new things.
We promote the idea that everyone is responsible for their own career. So to encourage this, we provide an opportunity for our employees to apply a self-promotion when they think they are ready. So at first they will actually do a self-evaluation, and thereafter there is a technical assessment and a panel interview to see if they are qualified to move on to the next level. And we have actually received positive feedback from our employees, even for those who fail the assessments, because it's very important for the assessors to provide constructive feedback on the improvement areas for them to work on and prepare for the next round.
I like the way it works here, where it's actually a very flat structure and organizations. So if I have some ideas or opinion, I can actually talk with the person in charge without going through a lot of layers. And that also means I either follow the rules or policy, or I participate in changing it. If I change it, it's shape environment according to what I want. That gives me a sense of ownership in creating an environment that I actually want to work with.
Hai Scrum Antusias, sesi selanjutnya.
Okay, so good morning, guys. I'm here to present to you today 9 design principles we use at iPrice to help us deliver features faster and safer. First, why do we need these design principles at all? First, well, design principles helps us not only to have maintainable, reusable code bases, it also helps us to facilitate the communication of your ideas within the teams. Clean, with good design, your codes are, again, maintainable, reusable, and more robust, more accepting the changes. If you have bad design in your code base will be hard to understand, hard to maintain, logic will be tangled, your data will be hard to follow, and even small changes to the software requires you to read huge chunk of codes to make the changes. What that entails is the confidence level of changing the software becomes lower, and it increases your testing time because you don't know what's going on. Solid, and we have popular design principles that are widely used and widely encouraged in the software industry, but the problem with this is the solid and design patterns are too advanced for most the software developers actually. The thing about this is they require prior knowledge of basic fundamentals of software design to actually use them properly. And the thing about this is when you teach them, when you ask developers to actually learn these things, what they do after learning this is they actually get excited to apply these patterns and principles to the problem, even if the problem does not require the solution presented in these principles. And that is actually worse than having no design patterns at all. So we introduced to you GRASP. GRASP is a set of principles that are tried and tested, and these principles encourages you to look at your software elements and where to assign responsibilities. So for this talk, I'm going to have we're going to explore GRASP by building the simple checkout system that has the following functionalities. And the diagram you see there is just a partial domain model. We will evolve this along the way by applying the GRASP principles. First, the principle of the creator. So, creating an instance of a class is actually a very common activity in software development. So it makes sense to have a principle that would guide us on where to invoke this new keyword in our classes. So the creator principle tells us that assign class A the responsibility of creating an instance of class B if class A aggregates or contains class B, if class A closely uses class B, if class A records class B, or class A has the initializing data for class B. Let's look at our example. Who should create an instance of line item? Looking back at our partial domain model, since order contains or aggregates line item, then it makes sense to assign order the responsibility of creating a new instance of line item. Well, it's very common to see in software development where invoking the new keyword is being assigned to a different class that doesn't really care about this object creation. And since we have this, we identify that the order should be responsible for creating line item, then we add a method in the order to create the line item. Now you may be asking, if that's the case, then who should create the instance of a product? Since line item is described by a product, so line item closely uses product, does line item should be responsible for creating an instance of product? Of course not. Because again, this is a partial domain model. In a complete domain model, you will have a product catalog. And a product catalog satisfies more criteria than the line item. A product catalog aggregates the product, has the initializing data for product, and closely uses products. So, if then it makes sense for the product catalog to assign the responsibility of creating the product. Next is the information expert or the expert. Assigning a method to classes is also a common activity in software development. Like, where should I assign this method? To which class should I assign this method? This method fits this class, or this class, or this class, but which is the optimal class to assign a method? So what the expert principle tells us is to assign a responsibility to a class that has the information needed to fulfill the responsibility. It reminds us that objects do things related to the information they have. So we need to co-locate those responsibilities with the objects. For example, who should be responsible for getting the total amount of an order? Looking at our partial domain model again, we ask first, what information do we need to calculate the total amount of an order? First, we need to know about all the line items and the sum of their subtotals. Now, since the order knows about all the line items, we assign the order the responsibility of calculating the subtotal, the total amount of an order. But we're not done yet. We mentioned that we need to also know the subtotal, and subtotal is computed by multiplying the quantity, line item quantity, and the product price. Now, who knows this data, this information? Since line item knows its quantity and its associated product, the line item should be responsible for calculating its subtotal. And since the product knows the information about its price, then the line item will just ask the product for that information in order to calculate the subtotal. So in here, we actually have multiple classes that collaborates in order to achieve a responsibility, which is, in this case, the creation of the calculating of the total amount. Next, we have the controller. So it's also common in software development where you have a UI, of course. Your software will always have a UI, be it HTML, API, app, or even CLI, command line interface. What the controller tells us is to assign a responsibility to the object beyond the UI layer to collaborate or to coordinate or to control your business objects to achieve to fulfill a responsibility. Now, you may be thinking here that for web developers, it's pretty common to have HTTP controllers that comes with your favorite frameworks, like Laravel has HTTP controllers, Symfony has HTTP controllers, right? But that is not the controller that's not the same as the Grasp controller. That controller is the one representing your HTTP. And your HTTP is the highway between your client and your server. It should not have any business logic in there. It should only take care of accepting requests and creating response, taking care of HTTP concerns like headers, status, response status, and all those stuff. You should not put business logic in there. That is what the controller is for. Now, controller suggests two ways of how to pass an object to a responsibility to an object beyond the UI layer. First is a facade controller and the use case controller. So facade controller represents a system or a subsystem in your application that has highly cohesive responsibilities. Highly cohesive means highly related responsibilities. And the use case controller represents a use case or a set of use cases in your system. Now, how do you decide which one to use, a facade or a use case controller? If your system has very small and highly related set of responsibilities, then it makes sense to use the facade controller. But if your system has more responsibilities, more commands that it accepts, then it makes sense to use a use case controller. The benefit of this is reusability. Since you encapsulated your business processes in the controller, the Grasp controller, you can just reuse that controller if you have different UIs. Let's say, for example, you have HTML. First, you started your business with HTML, accepting data from form posts. And then, next, you upgraded your business to accept also apps, mobile apps. And mobile apps communicate via API. You don't need to recode everything, for example, to create an order or make a payment. You don't need to copy the codes for creating order or making payment in HTML controller and RESTful controller. Next, we have low coupling. So, object-oriented design is an activity of designing objects that collaborate in order to solve a software problem. And collaboration of objects requires some level of coupling. It means, coupling means how is a measure of how a class is connected to, or has visibility of, or relies on other elements in order to perform a responsibility. Now we have this example here. So first, low coupling tells us that to evaluate always our design so that increasing coupling does not have negative effects on the overall design. Again, coupling is necessary in object-oriented softwares, but we need to always evaluate our design so that we do not break things. So here, let's say we are now accepting or handling payments for our orders. We have payment, checkout, and order. We already identified that checkout is our controller. So how should we structure these three classes in order to achieve low coupling when handling payments? Design one, since in the real world, the checkout records payment, then by the virtue of the creator pattern principle, it makes sense to assign the checkout the creation of the payment and then associate it to the order. And then we have design two, where the checkout just collaborates order to create its own payment class, instantiate its own payment, and then associates it with himself. So design one here, in any case, design one or design two, in any case, we assume that the payment will be associated to the order at any given point in time. Design one here creates visibility from payment to checkout. So the payment becomes visible to checkout unnecessarily. Why? Again, checkout is a controller. Controller coordinates objects. Coordination of objects requires sending objects messages. The thing about this is it's not sending messages to objects. It's just creating a new instance of object and immediately associating that object to the order class. Design two, checkout can only see the order. So checkout has lower coupling now with these two classes, which is payment and order. And then order, since in the end order will always be associated or will be linked to payment, then it makes sense to use order 2 because it supports lower coupling. So if you see here, checkout has two lines connected to it, and there's an indivisible line in here that actually has an association. High cohesion. Cohesion is a measure of how related an element's responsibilities are. So, a class, for example, that has low cohesion, that does a lot of unrelated things, is hard to maintain, hard to read, hard to reuse even. Because you're going to drag all those unrelated things along with it in order for it to be used. Again, we go to the example of the previous example in order to explore high cohesion. So, we already know that we don't want design 1 because it doesn't support low coupling, and we prefer design 2 because it supports low coupling. But actually, design 1 also does not support high cohesion because, again, the responsibility of a checkout controller is to coordinate. And now, in design 1, it's also participating in creating the payment when it doesn't really need to. It just needs to coordinate stuff. In design 2, checkout is very focused on its responsibility to just invoke a message to the order class. And the order class is also focused on responsibilities concerning the order, the payment. And next we have polymorphism. Polymorphism, a lot of developers say that, ooh, I learned it at school, why should I learn this again? The thing about it is we see still that a lot of developers don't know how to properly use polymorphism. Polymorphism is just a fancy way of saying to give the same name to a service, to different services or different implementations in different objects. Now, how do we use that? Example, you have this switch statement for calculating the discount. Now, how do we calculate the discount? Let's go again to, let's revisit the expert principle to find out first what do we need to calculate, what information do we need to calculate the discount. First, we should know about all the line items and the total amount. Then it makes sense to put this logic in the order class. Now the problem with that is the order class will be overburdened of not only knowing about the configuration, but also thinking about what implementation of the discount scheme should it use, instead of just calculating a discount. So how do we fix that? What the polymorphism principle tells us is to create a class from each of these cases and then assign those classes to polymorphic operations. Polymorphic operations are just operations that have the same signature as each other. So in here, we actually maintained high cohesion because now the order, if we set it up with the correct discount calculator, the order now just knows about the order calculator. It doesn't know about how the order calculator has been instantiated, how it's been put there. It just knows about, it just needs to care about invoking that discount calculator to get a discount. And then these two discounts schemes here are also focused on how they calculate each other's discount based on these schemes. And what did we achieve here? What design pattern does this look like? It looks like a strategy design pattern or adapter. It depends on how you see it. So this is an example of achieving actually design patterns based on the motivations and the fundamentals, which makes more sense than actually just learning design patterns from mechanisms and how to use them. Next is pure fabrication. So let's say you religiously follow the principle of expert, the information expert. Of course, a class can have a lot of information. And then software system has to do a lot of stuff with those information. So if you follow the principle of expert, what happens is you might bloat this class that contains the information, making it less cohesive in its responsibilities. What the pure fabrication offers us is that if you see that following this information expert or creator pattern or creator principle makes your classes or your elements less cohesive and has higher coupling, then create a purely fabricated object and shift some of those responsibilities to the purely fabricated objects to maintain the purity of the original class and the fabricated class. Example, let's say you need a formatted version of your data. Of course, formatting is presentational concern. It doesn't concern your business or whatever. You don't calculate stuff using the formatted strings. you calculate them using the primitive types. Now in here, you see that, of course, you format it, for example, you want to format the total price. Of course, the order has the information to achieve this responsibility. So it makes sense to follow the expert principle to assign this responsibility to the order class. But imagine if you have 10 or 20 data that needs formatting. It will bloat your order class. So how pure fabrication helps is you shift those formatting responsibilities to another class to maintain the purity of the original order class, and your order presenter now will just take care of the formatting. You have now two pure classes. Focus has high cohesion. Next is indirection. Again, coupling in software systems are necessary, but the principle of low coupling tells us that just maintain it low. Don't increase it in a way that will have negative effect on your software systems. But if you cannot maintain the low coupling, then it makes sense to have an indirection. Indirection tells us that to create an intermediary object to keep the original object's focus with the coupled objects. How does that look like? So for example, we handle payments. When we handle payments, we need to log the payment, the information, the date maybe, and to send analytics. In this case, order will be coupled to the logger object and the analytics object. The problem with that is order now is not pure anymore. It also takes care of, it also has visibility, has knowledge of the logger and analytics, and takes care of formatting the data to send to those guys. So what indirection tells us is to create an intermediary object so that you maintain low coupling with the original class. So it looks like this. When you make a payment, we created the order probe as the intermediary object. When you create the payment, you ask the probe that, hey, dude, I created a payment. Here's the data, do your thing. And then the order probe will take care of sending those data to analytics or logger or whatever. But it still has, it's still not good enough. Order here is not pure enough. It still has this a bit of, it lowers a bit the cohesion and increases the coupling a bit. We can still improve this one. So in here, we created a class that extends from the order. We call it probe order, and it will take care of making, invoking the order probe to send the data to analytics and logger. That way, we maintain the purity of the order, and we maintain the purity. We created another object, another class, that also is pure because it doesn't care about how to create a payment, this probe order. It just cares about, it just waits for invocation that another payment has been made, and then it will invoke the order class, or order probe, to send the logger and data. And order probe here is also pure. It just takes care about the sending of analytics and logs. Oh wait. So what does this look like? This one actually looks like a decorator pattern. So the probe order decorated the original order instance and added ability to it to send to the different loggers. Now again, an example of how Grasp gives us motivation to apply design patterns, not only the mechanisms. Now, protected variations. Protected variations tells us that to design objects so that the variability, variations and implementations, the logic, and instability will not affect other classes very much. So variations will always happen in software development. You have varying data, variations of user interface, variations of hardware or whatever. But how do we design classes or our object-oriented systems so that those variations will not have negative effects on the rest of the elements in our software? This is actually a root principle and mechanism for the solid or design patterns. If you realize it, single responsibility protects other classes from changes from another class. Open close says a class should be open for extension, but closed for modification. That means it protects the original class from extensions of other classes. Let's look at the example. Actually, a lot of our prior examples here are specializations of protected variation. So for example, here, in the information expert example, what this get subtotal does is it protects the order from changes in data, for example, in the product price. Let's say we change the way how we calculate the subtotal. Let's say we introduce a data in the product class called sale price, and we use that sale price instead to calculate the subtotal. What happens now is, if we assign the order the sole responsibility of calculating the total, then it will be affected by the change in this class, which is a stranger to it. And this one, the controller example, we protected our business from varying UIs, user interfaces. We could have HTML controller, RESTful controller, we could extend this to CLI or whatever, but it does not affect the way we handle payments, for example. It does not affect the way we create orders, for example, because we protected it using a controller. Again, this one protects from varying implementations of discounts, open, close. And if we want to add another discount scheme in the future, we don't need to worry about it. We just create a class, assign it polymorphic operation, and then inject it. The order does not care about it, won't be affected by the change. The presenter, we protected the original order from changes in the formatting. This is single responsibility because the frequency of change in the presenters or the formatting will always be different than the frequency of change in the original order class. The formatting for example, the date format would be month, day, year, today, and then we change it to year, month, day, some other time, but we don't need to affect the original order class for that. And this one, the indirection example, it protects, again, the original order class from changes in the order probe. Let's say, for example, we extend the order probe to also accept other probing mechanisms, aside from logger and analytics. You don't need to change the order class, or the order class does not need to be affected by those changes. And that's where we end the grasp examples. Actually, these are just very basic examples, but if you learn this and you apply this in your company, it will, even the information expert itself will have profound effect on your code base. And yeah, thank you. If you have any questions, please feel free to ask. No questions? Yeah.
Hello, my name is Iqbal.
Hello, Ima.
I want to ask you a question.
Mhm.
It should be not technical to answer. The first question is, what kind of architecture do you use when applying this graph? Is it mono or microservices?
So you can actually apply this in monolith or microservices, but it makes sense more in monolith because in monolith you have a lot of classes in one code base. In microservices you have just few classes in your services. But the thing is, if you apply this, you can apply some of this. What do you call this? Some of these principles in microservices, especially the creator and the expert principles.
Did you apply it in every every object? Locker doesn't need really complex layering, isn't it?
Layered architecture.
Did you apply it in every domain, every object?
Yes, actually, you can apply this to every domain object, even in service layers. Like, what language do you use, for example?
Node.js.
Node.js. I don't know. But actually, this is applicable in every layer of your architecture. Basic layers are UI, your domain, and your infrastructure. And yes, it can be applicable as what I showed you, what I showed earlier. Like for example, the controller principle takes care of varying UIs.
Last question.
Mhm.
When would be the best time to apply Grasp? Let's say I have an application using only 2 layers, controller and data access. When would you suggest I use Grasp? How many lines of code?
Okay. So the thing is, you only have controller, which I assume is an HTTP controller to accept request.
Yes.
And then you have data access.
Yes, only 2 layers.
Okay. Again, in this case, you don't really need to apply anything. And why? Even other design patterns, other solid principles, you know why? Your data access uses framework, right? Even your controller uses framework, right? And this framework are already tested, already proven. I mean, because they come from other authors, right? So they tested them, they improved them, it's probably open source. Then just use this data access and controller directly. You don't even need to wrap this in a controller, in a Grasp controller or anything.
I mean, the controller and the data access is slowly growing until it become massive files. When would you suggest to use the Grasp? When do you suggest to refactor the code and to using Grasp
But
architecture?
there is no computation, just data access. But then your data access becomes bigger and bigger, right?
Yes.
So what you need to do is apply the controller pattern. The controller pattern, I mean the controller principle, use the use case controller scenario. The use case that represents use cases. Because all your data access can be grouped in different use cases, I think. Is that correct? Like for example, can you give me at least 3 data access that you're talking about?
Let's see. We choose just the order controller and order data access gitu. Just one object. But it's growing rapidly. My question is, when would you suggest to use Grasp? How massive of a file would make you to use Grasp controller? I mean, if it's only crude, you don't need Grasp yet.
I don't think you need Grasp for very basic data access.
Yeah, when would be the best time to use the Grasp? How massive of a file would you suggest?
How
to start?
massive?
Yes.
How massive is the file when you start using grass in any size? The grass is for looking at the responsibilities of an element and making those responsibilities very related, maintaining the relationship between those responsibilities, or highly related, or however you say it. So, Grass is about where to assign responsibilities. So let's say you have small class or small file that only has two methods, let's say, or two commands it accepts. But these two commands are not related at all. Then you should break that class into multiple classes so that this class does this and then this class does this, which maintains its cohesion. Because how? Because why? The evolution of those classes will be different. They will evolve in different ways. So it makes sense to create different classes for them.
So you mean as soon as it is needed, you use it?
Yes, but actually you start Grasp during technical planning. Not really by looking at the files and, oh, this is getting big, no. So you use it because for example, you have a sprint. In sprint, you have planning. And in planning, you know the features you're going to implement this sprint, right? So from there, you determine, okay, this feature will need this. Okay, let's design this as this. That is where you actually start applying Grasp by diagram, using as early as planning, technical planning for diagramming and all those responsibility, assignment relating stuff.
Thank you.
Welcome. Yeah.
Hello.
Hi.
My name is Iksan.
Hi, Sam.
So there's two questions from me.
Mm-hmm.
Okay. First of all, is this graph stuff? Okay. Is this graph stuff is to solve, let's say, programming problems, specific programming problem, or decide the whole architecture of your application?
It covers the whole architecture of your application. Because Grasp is a set of, again, tried and tested principles that is collected and are applicable to most software engineering problems.
Okay, cool. And then the second one. Let's say I'm a dumb person. Okay, let's say I'm a non-technical person.
Okay.
And refactor my code base, okay, into this Grasp stuff, okay, takes time. Okay, and how do I convince the non-technical person? Okay, let's say I need more time to refactor my code base into this Grasp stuff, because I cannot just say like, okay, this is a good pattern that I got from a conference.
Good question.
Thanks.
So, I'm gonna tell you a story, but don't tell anyone. iPrice code base actually sucked. Okay? But we applied this Grasp silently. How? There's a refactoring pattern called what do you call this? Forgot. Strangler. You can read about that, but basically what Strangler does is, or describes, is, I'm sure you guys here in Indonesia have this kind of tree where a tree grows and then another tree grows around it and slowly and surely kills this tree, the original tree, and then flourishes this other new tree. So you can apply Grasp by doing that. Slowly and surely migrating your classes, your methods to Grasp, but still continuously delivering value. You do not tell your business people, hey, I need to refactor. You do not tell that. Because they will tell you, okay, let's refactor this later. And then in refactoring, always, later means never. Yep.
Check. Hi. I'm Dimpos. So I previously you said that I think you apply this on iPrice, right? So I'm curious, what's your previous architecture?
What kind of, architecture?
Yeah. I mean, is it monolithic, microservice?
Monolithic.
So then you apply this. I'm curious about the performance improvement on the iPrice. Before you do this, let's simply say the response time is about 100 milliseconds. After I use this, the response time is 10 milliseconds, or anything you can measure, or maybe we cannot measure it.
You can measure it. So actually, when you have good design, that means you abstract a lot, right? And abstraction creates layers, and these layers creates communication bottlenecks, right? So when you abstract a lot, you increase actually the response time, the processing time of how a software responds to a request. But the thing is, if you have a good design, you can eliminate also a lot of, like for example, queries. You can eliminate those if you apply those grasp principles. When you eliminate those queries are actually takes longer than abstractions. And example is, we have this price comparison feature in iPrice, which actually sometimes crash because of timeout problems, because we are sending a lot of queries. We did not group the queries because we don't know how to design this stuff. And actually it crashed. Sometimes the request crashed because of the number of products we need to display to the price comparison page. And we refactored it to Grasp. Now it can handle any pages, any amount of products in the price comparison page.
So there is no specific measurement or quantification for this. Do you measure
Milliseconds in New Relic.
Okay, so the next question, my last question is, you have 9 principles. I don't think you use all of them intensively. Which 3 principles is the most you use?
Expert, creator, and if I'm gonna choose, polymorphism. Because they're the ones that are easier to understand.
Thank you.
Thank you.
Hi Sandyandi.
Hi.
I'm Jonathan. Hi, by the way. Thank you very much. I would like to ask whether there is any part of the grasp principles that does not comply with, let's say, like Solid or King of Wood.
Does not comply.
Does not comply.
Yes. Expert can fail, can violate high cohesion. And when you fail, okay. Do you know cohesion is the fundamental principle of the S in Solid, the single responsibility? Single responsibility is actually a relaxation of the principle of cohesion. So, okay, that's that. If you apply again expert too much, you follow it religiously, you will end up with bloated classes, with low cohesion. And when you violate low cohesion, since low cohesion is a fundamental idea of single responsibility, then you fail single responsibility.
Thank you.
Welcome. No more? Okay. I think that's it. Thank you guys for having me here, for listening. And I hope to see you guys next time, next year. Thank you.
Hai Scrum Enthusiast, saatnya makan siang. Jangan lupa kita kembali lagi jam 1 siang untuk masuk ke sesi selanjutnya. Selamat menikmati!